Okay. What we want to talk to you about today is the integration of Neutron and BGP VPNs. So, as you may or may not know, what is called BGP VPNs is actually standard extensions to the BGP protocol to build multi-site layer 2 or layer 3 networks. These are actually very well-known technologies for network providers, deployed for many years in these networks. So what we mean by what these BGP extensions do is actually rely on routing to announce that the destination is reachable through a specific host, IP address, and use encapsulation, typically an MPLS encapsulation, but not necessarily MPLS, to isolate the traffic from the different virtual networks. So these techniques are well known in provider networks, and we want to actually integrate them into Neutron for actually two use cases. The first one is related to connectivity between OpenStack and BGP VPN, which are outside the data centers. This is actually required to have a seamless solution for hybrid cloud, multi-data center, and solutions for allowing a cloud operator to interconnect with a network operator. This is a very important use case in the case where the same player is both the cloud operator and the network operator. The second use case is actually pretty different and consists in relying on these BGP VPNs to build neutral layer 2 networks. The benefit of this approach, as we will discuss a little bit later, is the proven scalability of this design. So what we'll see in this presentation is how we can address these use cases, with a focus on minimizing complexity, reducing the number of protocols and components added in the whole architecture, and code reuse. So Mathieu will talk about the first use case.
Thank you, Thomas. So, as Thomas told you, this use case is about connecting external MPLS VPN to internal Neutron networks. So to do so, a new API extension is proposed. With this API, an admin can describe a BGP VPN connection based on root target information, and a tenant can potentially plug its network, its Neutron network, to the BGP VPN connection by updating the BGP VPN connection. So our goal is to design a reference implementation for this extension. The proposal is to implement this extension through a service plugin, so that any other implementation can be easily plugged by developing one's service provider or service driver. The service driver that we are proposing will talk to the VPN agent, which is an extension of the L3 agent. It already exists in Neutron, and it is in use by the IPsec extension. And the VPN agent and the BGP agent will be used to advertise and discover external routes. So those agents and the VPN agent and the BGP speaker will have to add new routes to the QRouter namespace and push and pop MPLS tags in the OVS bridge. So now I will tell you about the status of this work in Neutron. So currently we have the API extension proposed by Mathieu Rohon, who is a core member of Neutron. So it is under review currently, and it has to be updated for Kilo. We also have a compatible BGP speaker named Bagpipe, which has been disclosed, and it is available on GitHub. So it's important to note that this BGP speaker is very lightweight, and it is reusing the BGP encoding of ExaBGP BGP speakers. And we also have MPLS capabilities in Open vSwitch. So as we can see, we both have control plane capabilities thanks to the BGP speakers. We have data plane capabilities thanks to latest OVS. So we have proposed a design for the reference implementation, which is based on existing Neutron components. So this design is under review and under discussion currently in Neutron. It is important to say that other Neutron plugins and or mechanism driver could also leverage the new API. We are thinking of OpenContrail or Nuage networks which have also MPLS capabilities. So there are other related work in progress in Neutron. There is, of course, the BGP dynamic routing, which is under review, and that needs also BGP speakers. Service chaining work in progress too is very important for us to be able to chain a BGP VPN connection with firewall as a services, for example, or with load balancing services. And the L3 agent refactoring is important for us, of course, because the current design is based on L3 agent capabilities. And it could also be interesting to distribute MPLS capabilities on compute nodes. This is something that we are thinking about. It's quite similar to what DVR is doing, distributed routing in Neutron currently. And it is also something that is done in the use case B that Thomas will talk about.
Thanks. So use case B consists in actually relying on BGP VPN extensions to build Neutron layer 2 networks. So the architecture that we propose is actually to rely on overlay architecture, which is similar to other solutions existing today in Neutron. So VXLAN encapsulation is used to encapsulate VM to VM traffic. This encapsulation is done by the vSwitch. What we propose here, which is particular, is that the forwarding table of the vSwitch would be populated by the BGP VPN extensions. So, as Mathieu mentioned, we are focusing on an option consisting in having a lightweight, very simple bare-bone implementation of BGP VPNs. And the other important point to mention is that we don't use the layer 3 BGP VPN extensions, but the recent Ethernet VPN extensions that have been defined in the ATF, and which allow to emulate layer 2 networks, Ethernet layer 2 networks. So the reason why we think this is actually a good idea to do this is that the architecture of BGP VPNs has been proven for its scalability in the past. We have today operators network which actually deploy millions of VPN sites using these techniques, in particular rule reflection techniques with publish subscribes mapping distribution. And the second reason why we think this is something important to do is that it will allow an interoperability between Neutron overlays and endpoints which are on physical top-of-rack switches made by hardware vendors. So one thing that we can mention too is that this use of BGP VPNs is quite similar to what we can find in solutions such as Nuage networks or OpenContrail, but here with a very lightweight approach and something that will be built into Neutron. So today we have had running code for months. We have actually an ML2 mechanism driver for this backpipe proposal. We have a backpipe agent running on compute nodes. And we have the BGP VPN implementation that Mathieu mentioned earlier. So the next step for us is actually to push this mechanism driver for Kilo and the corresponding agent. And the second work item is to actually pick an open source route reflector, which is actually used to dispatch the BGP routes between BGP implementation and compute nodes. So there are different open source options here, which are interesting to look at. We have also, as a backup solution, existing commercial solutions for BGP route reflections. And more, beyond these close next steps, we have work in progress to integrate with third-party EVPN top-of-rack switches, work on also on inter-subnet connectivity, and work on service chaining. So let's wrap up. Use case A is a use case that is very important for network operators. The integration of Neutron with BGP VPNs that are outside the data centers. And use case B is actually not a use case that we need to address as an operator need, but as it's more like an opportunity for scaling Neutron layer 2 networks inside the data center. And that's actually relevant for pretty much everyone. We didn't say SDN or NFV during this presentation, but of course, it is what this is all about, except that here, we try to provide all these features directly through Neutron with less additional components than the typical SDN branded product. So the next steps, as you understood, is Kylo integration, if this is possible, but we are also considering alternatives if this is more realistic. So if you want to help, you can actually contact us, follow the blueprints, or discuss on OpenStack Dev. You can also follow the projects through the GitHub repository of the BGP speaker and follow the tweets on the account on the slide. We're done? Thank you.